As part of Singapore's Great Digital Twin, this demonstration illustrates how a distribution network twin supports and improves infrastructure planning for future demand. We developed a network twin of 22 kV distribution grids serving 7 towns. The model comprises a power flow model of 22 kV rings in Mesmo, which is a software for power flow computation and power optimization. We use the network twin to simulate network flows in different electrification scenarios and developed a dashboard to visualize and analyze the impact on the distribution grid. Our study is part of the Singapore Integrated Transport Energy Model project, also known as SITEM. The objective of SITEM is to perform a comprehensive impact analysis and policy recommendation study of vehicle electrification on Singapore's transport and energy system by modeling and simulating mobility behavior, charging behavior, and the distribution grid. This dashboard visualizes the results of network flow simulations under different electrification scenarios in the SITEM study. It is organized into 3 sections. The top left segment is a selection panel which controls the type of information displayed in the rest of the dashboard. Secondly, the top right segment is a geographical view of substations and electric vehicle charging sites. Lastly, the bottom panels provide aggregate statistics for the scenario, such as the distribution of type of charging points, the cost of corresponding grid infrastructure upgrade, the aggregate demand over the time of the day, and the distribution of transformer peak utilizations. All figures and numbers shown are for illustrative purposes and are based on anonymized and randomized data. For illustrative purposes, we consider 2 vehicle electrification scenarios in the years 2030 and 2040. These are aligned with one of the key targets of the Singapore Green Plan 2030, which seeks to encourage adoption of electric vehicles. Charging loads for both scenarios are obtained from island-wide vehicle mobility and charging behavior simulations in a software called CityMOS. Switching to a different scenario triggers updates to both the map and bottom panels. Users can also investigate the impact of alternative concepts of operations, such as smart power management, that simulates the impact of intelligent charging load control on reducing peak load. We developed geospatial visualization tools for the distribution network twin to support EMA and SP in evaluating the adequacy of distribution system capacity. The map displays an overview of the utilization of 22 kV transformers in the 2040 electrification scenario. Substations are color-coded based on transformer peak utilizations, with red denoting heavily loaded transformers and yellow denoting lightly loaded ones. This makes it easy to identify substations that face the most stress and prioritize them for further studies. Users can obtain transformers peak utilization values by hovering over specific substations, or 22 kV ring peak utilization values by hovering over 66/22 kV substations. These utilizations are computed from power flow simulations using the network twin. Beyond island-wide assessment, users can also study specific locations easily by interacting with the map. For example, by zooming in to the Queenstown area, information on Queenstown is updated and reflected in the bottom panels. This enables analysis of demand at more granular levels of single substations. To streamline upgrade planning studies, the tool makes it easy to access commonly used information. In this example, the grid upgrades required are shown when hovering over substations, and details on surrounding charging sites and potential demand are provided on the map. Users can also carry out network studies and planning by focusing on specific rings and visualizing the cable routes for the rings. In summary, this demo illustrates how the distribution network twin supports and improves infrastructure planning for future demand, and we look forward to expanding our model and tool with more features. Beyond this use case, the network twin provides tremendous opportunities to develop other innovative tools to streamline network planning and optimize the cost of network upgrades. Moreover, it can also be used to evaluate the impact of integrating emerging technologies such as distributed generation and energy storage into our network without the need for complex field demonstrations.